Perfect. We shall continue. So in this video, we're going to be talking about generating keys. Okay, so the whole key generation part. Generating keys. Okay, so again, whenever you want to encrypt something, you need a key. Okay, before you encrypt something, you're gonna need to have a key. A key needs to be generated. We've talked a little bit about this, and so this topic will be a little bit about, touching a little bit what we covered, and just giving you a brief overview on again, the key generation part. And so doesn't matter if it's a temporary session key or a more long-term public and private key. It must be generated randomly because it is the crux, as the author says, of security, of cryptographic security. The sauce, the meat, I don't know what to say, the main part of the cryptographic security is the key. We know this already. So for example, with HTTPS, you get a public key from a website, and from there you generate a symmetric key that is going to be active for your session to encrypt the data. Right? And these public and private keys that are involved in HTTPS, for example, they have a life of years. The website keeps a key for years, so they need to be very randomly generated. They need to be very important. So it's not always simple to generate keys, and we can do it three ways. So we can do it randomly, straight up. Okay, by querying pseudo-random number generator and key generation algorithms. So basically, again, this is we ask a pseudo-random number generator for bits. Okay, we just ask and we get bits in return. Another way to generate a key is from a password. Okay, from the password. So we need something called KFD, KDF. Which stands for key derivation function. Okay, I'm too lazy to write, so remember it. And then a third way, through a what's called key agreement protocol. Okay, key agreement, so randomly password to a key agreement protocol, which the author doesn't explain too much, but it's basically a series of messages between two or more parties that result in everybody having a key. Okay, don't know much about the third one because the author wants to more talk about number one. Okay, the generating them randomly. So let's talk about again number one. Okay, let's go back in the random generation, and we're gonna talk about, first of all, about symmetric keys. Okay, symmetric keys. Okay. Oh, we can call it 1A. Okay. Key generated randomly, symmetric keys. So symmetric keys, we know they're shared between parties, clearly to Bob and Alice. Let me just make the little. This is Bob, he's kind of doing a squat. And then Alice. If they want to communicate, this is a padlock, anonymously, and they want to have their communication protected, and they're using symmetric encryption, then they all need the symmetric. They all need to have the symmetric key with them, okay? So, when a key is generated, when a symmetric key is generated, basically the length is equal to the security level. That means that a 128-bit symmetric key has 128-bit security level, okay? And so that means that there are 2 to the 128 possible valid keys, okay? So this is what's all about. And so how does it work in practice? And I'm gonna show after the board, I'm gonna go to the computer and show you really quick how I generate these keys. We just ask a pseudo-random number generator for 128 random bits. Okay, we have separate engine for 28 random bits, and we can use, for example, Open SSL tool. This is a little program that we have in every that we have in the computer, and I'm gonna use, or at least in Mac it's installed. I don't know, Windows for sure. Linux is there. I'm gonna use OpenSSL in a very quick demo after to generate a symmetric key. Now we talk about symmetric keys, which are shared keys between two parties. What about asymmetric keys? We talked a little bit about asymmetric keys before, right? And so let's go to B, and we're into the asymmetric. That's an ugly E. Asymmetric keys, okay? So what can we say about the asymmetric keys? The length no, it's different than the security level. Okay, and we're gonna see in a little bit why, for example, especially in the case with RSA. Usually longer. Okay, so I should say length is bigger than the security level, right? They're longer. Why? So why isn't as straightforward as puking out random bits and that's my key? Why is not the case here? Why is it a bit trickier to generate? Well, because you can just get a bunch of random bits, put them together, and you have an asymmetric key. No, because asymmetric keys, they're not random bits. Okay, they're not random bits. Why? Because they represent a specific object. Okay, they represent a specific object that has specific properties, right? So what do I mean by that? Let me explain you this. Let's take RSA, right? RSA encryption has public and private keys. And why we cannot have an RSA private key? Why we cannot make a key just from random bits? Because RSA keys are huge numbers. They're a number, okay? They're not just random data, they're a number, right? Especially the private key is a number, and that number is the product of two prime numbers. So that's what I mean. I'm making a very specific example of what it means that they represent a specific object. In RSA, these keys represent an object, a number, okay? And that number is made by is given by the multiplication of two very large prime numbers, right? Which makes it almost impossible to find, and that's a whole. We'll get into the RSA, I think, in later chapters, but this is the gist of it. So since you can just spew out random bits, you need a key. A key generation algorithm, okay? What does a key generation algorithm do? It takes, let's say, as input, it takes a seed, okay? A seed, and the seed, this is what gives it the security level. So let's say we get a let me see how to write it down. Random bits. Well, I'm just gonna say it's basically the value of random bits as big as the security level. So this is what makes the security level, okay? This defines the security level. This is the randomized part that gets input into the key generation, and as an output you're gonna have a pair, or you're gonna have one public key and one private key, which are obviously related. And so this is what we need to know about generating keys for asymmetric encryption. Remember, it's not symmetric keys, they are a collection of random bits. Asymmetric keys, you need a key generation algo because each a key can represent a specific object with certain properties. And for example, in RSA, the private key is a number. I'll make example. Is a number. Example RSA, right? A number of, what is it? P times Q or K, I remember. But P and Q are two very large prime numbers. Okay, so that's the property that the RSA private key needs to satisfy, and that's why the length of the asymmetric key is always bigger than the actual security level they represent. Very good. So to conclude this brief video, how do we protect keys? Okay, how do we protect keys? Because we generated them, we have them. Obviously, we don't want nothing bad to happen to them. We don't want to lose them. We don't want somebody else to eavesdrop or steal them from us or read them from us. Because if not, we're screwed. So there's a thing called key wrapping. So we have three ways. One is, I want to make stars for each. Key wrapping. And here, basically, you're going to protect, you're going to create a key file A password protected. Actually, no, let me give you a more broad definition. Key wrapping is encrypting a key with a secondary key. Okay, so the way that works is that you create a private key and then you literally usually it's done in SSH with a password. Literally will ask you for a password, and from that password another private key is taken and will encrypt the first key. And so the gist of this is that you get a password protected it's called key file. Okay, and so which is usually stored in the local system. Okay, a secondary key, I should work with another key. Sounds better. Okay, encrypting the key with another key. That's what key wrapping is. Very simple. And you get a password protected key file. If the other key, let me do in SSH because I read the SSH example. If that another key comes from a password, amazing. Okay. Second method of protecting keys is going to be called on-the-fly generation from password. Okay, I'm gonna abbreviate on-the-fly generation with password. Okay, very long. What does this mean? It's kind of the idea of this one, but we do not have any file, any key file saved on our system. So that means, that's what it means on the fly, generation with password. That means that our key is automatically encrypted with a password. And that means that without getting access to any encrypted key file, I can already try to use these passwords to get my private key. Okay, and so with the password. Okay, now the author points out that the weakness of this is that the attacker can directly search for the correct password by attempting to decrypt the encrypted message with candidate passwords. And if the password is weak, the key is compromised. So being very careful here, because if we on the fly protect the key with a weak password, then we lost the key. Okay, it's almost like as if we're not able to protect it. And then the third way, it's going to be storing on hardware. Okay, storing on hardware. So, storing on hardware is when you have, I don't know, your personal smart card that you insert into a reader, and it gives you access to things on your computer, for example, or anytime you have some sort of physical device that you need to use as a key. And so the key, the cryptographic key, is stored in those hardware. It's called stored in secure memory. And a lot of times these devices will also prompt you a password, so they can unlock their memory and then give you let you use the key. It's the least convenient. It's the least convenient because you always have to carry something with you, and guess what? I don't know. You have coffee, you put things on the table somewhere, you forgot, you go away, and you forgot your key. And so that's one of the weaknesses, is that you can lose it. Okay, you can lose it. Well, the software-based solution, you can also lose it, but less likely than with a physical object. Okay, so yeah, just make a dongle, USB key, USB, just write USB, smart card, etc. Okay, so that's pretty much it for the topic of key generation and key protection. Why is a big deal protecting this whole topic? Because not only you need to protect them, not only you need to protect your keys, but you also need to be able to use them when you need them, right? Because if you're sending an encrypted email, you need to have them with you. And so that's why it's an important topic. So that's it, very basic today, very brief, very simple. We went over generating keys, 3 ways. We zoomed into the randomly generating key method, and we see how that applies into symmetric keys and into asymmetric keys. And then we kind of concluded with a brief section on how to protect keys. And I'm going to briefly go to the computer and show you how I generate a symmetric key, how I generate an asymmetric key, and how I do a key wrapping on a key to protect it. Okay, so let's go to the computer. Guys, thank you for watching, by the way. Yeah, but let's go to the computer. Alright guys, I think it started. Welcome to the computer. Let's do a very quick demo of what I talked about in terms of key generation. So I have here the documentation for OpenSSL, okay, a cryptography toolkit. Very cool. I suggest you to go to the docs and basically go through the commands, especially the one we're going to use. So today we're going to do 3 things: generate a symmetric key, generate an asymmetric key, and generate a symmetric, an asymmetric, and an asymmetric but wrapped with a key wrapping to show you how you protect it. So let's start with, I already have the scripts here. Where are they? Right here. And so let's try the first one, generate a symmetric key. So again, we said that to make a symmetric key, we just need to output random bits, right? So let's do this, open SSL rand, which outputs random numbers, 16 and encoded in hex. And so this is going to give us all these random characters that we did. And obviously we can go here and we can go exactly see, you know, what does the rand do, etc, etc, etc. Okay, so this is how you create a symmetric key. Okay, random bits, they're enough, and I'm gonna share this to the party that I want to communicate with, etc, etc, etc. But what if I want to create now an asymmetric key? Okay, asymmetric key is gonna use another command called gen RSA. We're gonna use RSA cryptography for this example. So open SSL gen RSA, so generate an RSA key, 4096 bits. Okay, so again, remember that the length of the key doesn't matter that it's 4000 bit security. That's not the case. Okay, so this is it. This is our RSA private key. Okay, this needs to be stored. This needs to be absolutely stored away because this is precious. This is a private key, and that's how you generate it once. And then remember, one of the the points of protecting keys was to do this thing called key wrapping, right? So key wrapping, let's test it, and let's wrap our symmetric key with an AES 128, okay? So let's do the same command, open SSL, generate RSA, AES 128, okay? And then 4096, the length of our key. Let's generate. Okay, now it's gonna ask me for a passphrase. Why? Because from the passphrase is gonna be what I use to encrypt this private key. Okay, so let's say hello world, boom, and this is it. Now you see that here we have encrypted, and we know that it's encrypted by AES CBC, which is a encryption algorithm. Okay, boom. So block cipher, which is actually going to be the next topic of the next chapter, so we're getting there soon. And so that's it. This is like just wanted to show you practically how this key creation process looks like, you know, on a practical, on a terminal, on a computer. And yeah, that's it for today. Keep in mind these few things. Keys are very important in cryptography, and thank you for watching. I'll see you next time. Bye bye.